Hey guys, so based on that brief introduction to binary numbers, now we're going to actually go ahead and try to convert decimal values to binary values and binary values to decimal values. But before we do that, let's talk a little bit more about the decimal number system. And so make sure that you have this worksheet along with me and try and take notes along with this video. So in the decimal number system, basically we have, like for example, the number 3 is in the ones place, then the number 4 is in the tens place, and the number 8 is in the hundredths place. And so each digit is separated by a factor of 10. So it goes 1, 10, 100, 1,000, etc. And so if I were to convert this value into its decimal equivalent, basically I would take, for example, I have 3 ones. So you could take the number 3, multiply it by 1, and you get 3. Then 4, I have 4 tens. So if I did 4 times 10, I would get 40. Then if I did 8 hundredths, it would be, literally, I have 8 100ths. So 8 times 100 is going to be 800. I have 5 1000ths. So 8 times 1000 is going to get me 5,000. And then I have 0 10,000ths. So 0 times 10,000 is going to be 0. And I have 1 100,000. And so that's going to get me 100,000. So if I were to take all of these numbers and add them up, so if I do 3 plus 40 plus 800 plus 5,000 plus 10,000, or sorry, 100,000. In the end, I'm going to wind up with the number 105,843. And so that's how you would break the number 105,843 into its decimal equivalent of that, right? So it's 3 plus 40 plus 800. And so you're going to see the same thing happen when it comes to binary numbers, except that binary numbers are only base 2. So let's take a look at an example of that. And so let me scroll down. And so if we look at a number with different bases, then if I were to take the number 001000101, this is 1 byte of data. And so there are 8 bits in every byte. And so a bit is just a name for either a 1 or a 0. And so just like we have a digit in our decimal system, we can have a binary digit, which is called a bit. And so I'm going to rewrite this number again. And so I spaced it out so that we can take a look at it kind of each digit at a time. And so this number is really just the same as this previous number up here. And so basically each digit in binary is not going to be separated anymore by ones, tens, 20s, or ones, tens, hundreds, thousands, etc. It's going to be separated by powers of 2. And so, for example, this digit is going to be 2 to the 0 power. The next digit is going to be 2 to the first power. The next digit is going to be 2 to the second power. The next digit is going to be 2 to the third. The next digit is going to be 2 to the fourth power. The next digit is going to be 2 to the fifth power, and these are all just powers of 2. The next digit is going to be 2 to the sixth power, and the next digit is going to be 2 to the seventh power. And so what do these values actually mean? So now 2 to the first power is just going to be, let me change the color here, is going to be anything to the 0 power is 1. So this is the ones place. The next value is the 2's place, because 2 to the first is 2. 2 to the second is 4, so the third value is the fourths place. And then the next one is 8, and the next one is 16. So see how it doubles each time? So instead of increasing by a factor of 10, it's increasing by a factor of 2. And then here, the next one would be the 32's place, and the next one would be the 64th's place, and the next one would be the 128th's place. And so here, basically what that means is that I have 1 1, I have 0 2's, I have 1 4, I have 0 8's, I have 0 16's, I have 1 32, I have 0 64, and I have 0 128. And so I can rewrite this as basically 1 1's, 0 2's, 1 4, so 1 times 4, plus then I would have 0 8's, I have 0 16's, I have 1 32, I have 0 64, and 0 128. And so I'm just multiplying each of these. And so in the end, this just becomes 1 plus 4 plus 32. All of the other values are 0. So I have 1 1, I have 1 4, and I have 1 32. And so in the end, if I add these up, just like I did in the previous example, I get the number 37. So that means that the number 001000101 in binary converts to 37 as a decimal value. And that's it. So that's how you would transfer from binary to decimal. And that's how that works. So I want you guys to try the next two on your own. So the number 11111010, what would that be in binary? And so I can start you off with this if you want. And so if you write this out and you put underline values underneath it, then you basically, the first value is going to be your 1's place. The second value is going to be your 2's place, then your 4's place, then your 8's place, then your 16's place, then your 32's place, then your 64's place, and your 128's place. And so now what you would need to do is just add up each of the numbers in order to calculate what the numerical value is. So try this on your own. Okay, and so the answer to the first one would be 250. And the answer to number 2 would be 153. And that's because 1 plus 2, 4, 8, 1 plus 8 plus 16 plus 128 would be 153. And so those would be the answers for number 1 and number 2. And so now let's do an example where we are just converting the opposite way. So now we're trying to convert from 21 and convert that into binary. And so in order to do this, we're going to go back and we're going to look at the numerical values for each of these things. So we're going to have a 128's place. We're going to have a 64's place. We're going to have a 32's place. We're going to have a 16's place. We're going to have an 8's place. We're going to have a 4's place. We're going to have a 2's place. And we're going to have a 1's place. And so I can't possibly have a 128 inside of 21. That's impossible because 21 is smaller than that. So I know right away I have to have 0 128s. For the same reason, I also know I have to have 0 64s. And I have to have 0 32s. Because you cannot fit a 32 inside of a 21. So I know that those have to be 0. Now, how many 16s can I have inside of a 21? I could have 1 16. And so if I have 1 16, right, if I have the number 21, and I already know that 16 of those numbers have been accounted for with this one binary digit of 16, then I know that I just have 5 left over to work with now. So now I have the number 5. I already accounted for 16 of those digits. And so now, can 8 go into 5? Are there any 8s in 5? No. So I can't have anything in my 8's place. But I can have something in my 4's place, because if I'm left over with the number 5, then there is 1 4 inside of 5, right? And so now I'm going to take 5, and I'm going to subtract 4 from it, and I'm left over with just 1. So I'm going to take the numerical value of 1, which can have 0 in the 2's place, and must have a 1 in the 1's place. And so now I know that the binary equivalent of 21 is 0, 0, 0, 1, 0, 1, 0, 1. And that's because it's 1 plus 4 plus 16. 1 plus 4 is 5 plus 16 is 21. So if I add all those up, that's what I get. And so this is my answer for example 3. And so now I want you guys to try and convert 192 into binary. And again, we can use that same thing. So we have a 128's place, I have a 64's place, I have a 32's place, I have a 16's place, I have an 8's place, a 4's place, a 2's place, and a 1's place. And so right away I know that 128 is going to be able to go into 192. So if I do 192 minus 128, so what is this? So I'm going to do 192 minus 130, I get 62, so this is 64. Ooh, 64 is a nice number. I want you guys to try and finish the rest of this. So how many 64s go into 64, how many 32s, etc. Okay, so in the end, in this one, you should have known that you're going to get 164 and then 0 everything else. And so your binary equivalent to 192 would be 1, 1, 0, 0, 0, 0, 0, 0. And so that would be your answer for number 4, and then, or number 3. And then for number 4, what's the decimal value for 255? That's going to be 1, 1, 1, 1, 1, 1, 1, 1. We would have to do all values of 1 in order to get 255. And for number 5, how can you tell quickly if a binary number is odd or even? So let's think about this. What do you guys think? How would you tell whether a number is even or odd based on just looking at its binary? And so the answer to this is just the last digit. So if the last digit is 1, then the number's odd. And that's because everything else is just powers of 2, right? And so here, the only time you'd be adding a 1 to a binary value or a binary number would be the very, very last digit, because 2 to the 0 power is 1, and so the very last numerical value that you're adding would be a 1. Everything else is 2, 4, 8, 16, and so those values will never, ever be odd. And so that's a really quick way to check whether a binary number is even or odd. We're going to talk a little bit more about binary numbers and how binary values relate to pixel values and colors, and so we're going to do that for next class.